Hello everyone and welcome to this session of our Digital V-Days. My name is Markus Eberle and I will moderate this webinar today, which is about wireless M-Bus technology, overview, benefits and comparison. I'm very happy to welcome the guy next to me, Michael Lang, who is Business Development Manager in the field of wireless connectivity and sensors. So yeah, interesting topic. Wireless M-Bus enables a long-range, reliable data transmission for smart metering. But what should you know about frequencies, licensings and flexibility? Let's dive in. Michael, stage is yours.
Thank you, Markus. And welcome also from my side to this topic about wireless M-Bus. And I want to try to give you an overview about benefits and also a comparison in the end. Where can I use wireless M-Bus and where is another technology better fitting? A very short introduction about myself. That's me, as Markus already said, business development for wireless connectivity. And if you have questions, you can contact me directly. About the points, what we want to have a look on today. First, about introduction to wireless M-Bus. What is it at all? History and evolution and technical overview and a comparison, advantages and disadvantages, technology-based comparison, a few use cases and a future outlook, where could it be used in the future, and also what are with electronic solutions we have here in this field of wireless M-Bus. And last but not least, of course, a conclusion to give you a hint how to use it or how it could be interesting for you. And of course, if you have questions, you can type it in and we will answer them in the end or afterwards. So to start with an introduction of wireless M-Bus. What is it? So there is a wireless. It is a wireless metering standard. It's based on the cable M-Bus standard and is a European standard for wireless communication for smart utility meters. Frequency bands are license-free ISM bands, which are used here in this case, and this offers cost-effective and suitable usage for device environments. It's a very flexible communication possible with wireless M-Bus. It supports both uni and bidirectional communication, and it's also, and it's an important point of course, the secure data transmission. It's an AES 128 encryption possible and included, and of course meter data is somehow private data and you have to have a secure connection on it. Typical applications are, of course, smart metering. Here an example also is shown on the picture on the right. Always where you have a metering application and you want to transmit the metering data somewhere, you can of course use cables, but not always you have a cable connection available. For example, here with the wallbox application, the current is there, or you have there the power connection, but if there is a data transmission available, that's always a question, and therefore wireless M-Bus could be a very good solution to have some kind of a smart metering solution there. Also for industrial monitoring applications, it's very interesting as it supports wireless sensor networks for an very good environmental and industry data transmission of data here. Smart cities are a very big topic, right? And you can assume it's very important to have here data, because data is king in the end. And so you have to sense data and sense energy levels in all directions, and therefore you also need it in smart cities to see where is power needed, where is power produced, and how could it be transferred. That's a very important topic also. And another application is are applications where robust communication is needed, because wireless M-Bus is a real stable communication and could be used also in difficult environments. So we come to the next point, the history and evolution of wireless M-Bus. How did it come to it? So we have in the 1990s, I already mentioned it, the M-Bus metering bus, it is called completely, and it's a wired communication bus. And in the 2000s, there was the wireless M-Bus introduced as a wireless alternative or wireless system based on the metering bus, to have a possibility, especially for meters and for the needs you have there, to send metering data. And it was, of course, also adapted and further developed to get more and more functionalities and bringing more and more benefits into the technology. And yeah, it is a very cost-effective standard, and this is also one of the aims of the wireless M-Bus standard, to bring it as cost-effective solution into the market. Behind it, there is the OMS, which is coordinating all the stuff of the standard of the wireless M-Bus itself. In all IoT applications, it's very important to get as much data as you can get to find the best solution, or to find the sweet spot, or to find points where you can save energy or time, or in the end money. And therefore you have to have some kind of sensor data, of energy data, of heating data, and so on and so forth. And here you need a solution, and wireless M-Bus can be one of it. First, for the smart metering enablement, that you have the possibility to get this data and, of course, to work with it. It can be integrated directly in AMI systems to advance the infrastructure in real-time data collection and to analyze it, of course. It's important for interoperability and for different ecosystems. You can combine different devices and devices from different manufacturers as meters, as smart meter gateways and things like that. And it's seamless integratable into each other or into one IoT ecosystem. And last but not least, it's a scalable and secure communication. The scalability is very important because if you can easily mention, like in the example here with the charging infrastructure, it could be needed to enlarge it and to scale it up. In the first steps, perhaps you have only a few points where you want to measure data, and growing this ecosystem I described before, it could be very important, or it will be very important, to have the possibility to scale it up and to have more and more sensors and more data in the existing system. And therefore, a scalability is very important, because it is the more effective, and of course with it also the more money saving in the end, if you can add sensors and sensors and sensors or data points to make it even more sufficient. With this, we come to the technical overview, what we have here in the wireless M-Bus communication. First of all, it's a star network topology. So you have one gateway and dozens, hundreds of slaves around it, sending data to this gateway. And as we heard before, also a bidirectional communication is possible. So you can also send information from the gateway to the nodes and bring information to them. It's a diverse communication modes available. So this S, T, R, F modes, different modes are available there, depending on the application and on the data level you have there to bring it into the field. All of them are based on different frequencies, as we also already heard before. Mainly in Europe, 868 megahertz are used as sub-gigahertz ISM frequency band because it's free of charge and you can use it in this industrial, scientific and medical applications as SRD bands, and so therefore again very cost effective. You can also use other frequency bands like 433 megahertz, or in some regions, mainly Southern Europe, they use also 169 megahertz. With the benefit of longer, even longer distances, you can bridge and can send data over longer distances. The third point, there is a protocol stack layer integrated into the wireless M-bus, and you can, or it is included, the complete RF and physical data link, and all layers are integrated in this wireless M-bus communication. And last but not least, again, and I have it here because it is very important, you have a secure communication, as this is sensible data in the end, or could be. It is needed to have a secure communication. You can think about, of course, nobody's interested in my energy consumption in my home, but if you get the energy consumption of a company or of special points of interest where you are, then it could be very interesting how many energy is used at which time, so you can see who is there at which time or when it is used or not. And so it's important to have a secure communication there. The performance and security features are shown here. And first of all, we have a very good communication performance. As I already said, sub-gigahertz communication makes it easy to realize ranges up to 2 kilometers or even more in special parts of the standard, in special modes. And you can send data from 2.4 to 100 kilobit per second. We have later on a comparison to other technologies, and there you can see wireless M-bus is quite good set up with these possible data rates. The power efficiency also is very important because you cannot, or you even have not the possibility at all to change the battery in some devices. And as you know, metering devices very often have this time scales of 8 years, then they have to be removed. And of course, you don't want to change the battery in this time. And that's very often easily possible with wireless M-bus. You get even longer battery lifetimes, up to 20 years in reality, but these 8 to 10 years is a very good option you can get with wireless M-bus. The costs, the operational costs are also quite important, right? And so you can reduce them with this, I already said it, with the license-free ISM bands. And so you can bring the costs down and have an easy deployment of further sensor nodes or energy points. And security, again, is here shown because also for the performance, some kind of security is very important, and that you have ensured for data confidentially and integrity in the end, so that you are able to send the data in a secure way. with this, we come to the point or the comparison with advantages and disadvantages of wireless M-Bus. And we want to start with the advantages. As we already said, long battery lifetime is possible. We also said or talked about the robust and reliable communication and the secure communication, and also the scalability we have shown already. So these are the main advantages you have to have for scaling up and enrolling more than a few measuring points, but to have a great or a bigger number of measuring points you want to scale and you want to measure out in the field. The disadvantages, of course, every technology has a limit, and also the scalability of wireless M-Bus has some kind of a limit. And yeah, you then have to bring in another gateway or more gateways for collecting the data. There is, of course, a limit. And you will see in the comparison to other technologies, in cellular applications, you have not this limitation in this grade here. The frequencies I mentioned, the sub-gigahertz frequencies, have one big problem. They are not worldwide usable. So the 868 megahertz are only usable in Europe mainly, and not, for example, in US or not in Asia. There you have different frequencies you can use in sub-gigahertz applications. And this is something you have to have in mind, that it cannot be used worldwide compared to Wi-Fi or Bluetooth, for example. Also, the data rate is one point. You don't have these tremendous data rates you have with Wi-Fi or also with cellular applications. The reason for that is, of course, wireless M-Bus was always made for meters, so you have to send really few data only. And it's not made for big data amounts, and this is something you also have to have in mind. And of course, there are also possibilities of interferences and performance issues, especially with some kind of cellular. There are some topics you have to have in mind, and yeah, you have to check if you bring something into the field, how it is working with other parts together. Now we come to the comparison. As I said, we have a table here, and we want to compare the wireless M-Bus with the well-known LoRaWAN and two special cellular solutions, LTE Cat-M or LTE-M and narrowband IoT. And I want to say a few words to every technology here. So wireless M-Bus already was shown, of course, and yeah, you know now nearly everything about it, I would say. No, just kidding. But LoRaWAN also is surely very quite well known. It's also an technology based on ISM radio frequency, so also the same frequencies, 868 megahertz, 433, 169 megahertz is usable here, with the same disadvantage, you cannot use it worldwide, and with the same advantage of long ranges possible. The cellular technologies, LTE Cat-M and narrowband IoT, are very comparable. Both of them are a special cellular solution. It's not comparable with the solution integrated in your phone, for example, because there you have very high data rates, and this is not the idea of these solutions. Narrowband IoT has it in its name. It's narrowband, so it's a narrow bandwidth, so not that much data could be transferred. And so now we come to the comparison, and the main advantage of the cellular solutions, of course, is the coverage. You do not have to do something for placing a gateway or something. There is a cellular coverage, and you can use this directly. So you can place a single meter somewhere or hundreds of them. The cellular coverage will handle it, and you don't have to think about it. Compared LTE-M and narrowband IoT, LTE-M has the higher data rate and also the higher power consumption, and the rest is very comparable. Narrowband IoT is with lower data rates and also with lower power consumptions described. Comparing to the cellular solutions, we have LoRaWAN and wireless M-Bus based on this ISM frequency ranges, where you can have the advantage it's much cheaper because you don't have to have these network costs, the cellular costs, but it's also depending. If I have 5 devices, it's one thing. If I have 5,000 or 50,000 devices, it's another point. And of course, both have, so the cellular and the not cellular solutions have different ideas in the back. And so the wireless M-Bus and also the LoRaWAN both have the idea, I place a gateway where I need it, and there I can collect data. Even in a basement where I don't have cellular coverage, I can place my own gateway there and collect data from, I don't know, 50 energy meters or something like that, and collect all data there to save, for example, wiring effort, and collect data there, and cellular would not work there because it's underground, and so you don't have cellular coverage there. So this is one benefit of the wireless M-Bus and LoRaWAN, where you have this ISM and can build an own gateway and collect data there. For both wireless M-Bus and for LoRaWAN, there are ready-to-use gateways you can easily integrate into your system. And of course, this is one thing you have to have in mind for all 4 applications or technologies. You have to handle the data. So you have to have a backend or some kind of a cloud solution or whatever to collect data and to bring it then into a dashboard or into a database or what you want to do with it. You have to do something further. In LTE Cat-M and narrowband IoT, it's a bit easier because it's already somehow in the internet, I would say. With wireless M-Bus and LoRaWAN, you have to have some kind of a bridge into the internet if you want to bring it into a cloud. But of course, you also have here the possibility not to use the internet, to have everything right local and not bringing it online. The data rates are also one difference between wireless M-Bus and LoRaWAN. You have much higher data rates with the wireless M-Bus possible, and in the rest they are quite comparable. In the table you have a higher range in LoRaWAN, but that depends very on the data rate. So it's quite the same, of course, because it's physically using the same frequencies and the same band you have in this ISM frequency range usable. Okay, so now we have compared a few solutions which could be interesting for metering applications, and now we want to have a look on a few use cases and also how it could be used in the future. And yeah, a lot of things I already mentioned. Of course, smart metering is very interesting for wireless M-Bus, as it is designed for especially that. So you can use it for monitoring, of course for billing. You can realize some kind of a resource management, and yeah, all there you need data, and therefore you need a solution. Of course you can collect it via cable, but some applications are very complex, and it's not so easy to bring a cable to every meter. and then a wireless solution could be very, very interesting. Of course, also industrial monitoring is interesting, and there not only the energy, but of course also could be interesting, but also other topics. And as I said, you can also send sensor data via wireless M-Bus and also via the other technologies I have shown. Smart city initiatives also need data to bring intelligent grids or something like that into the field or into operation. You have to know where is which energy produced and where is which energy needed, and to bring it to the right points, of course, you have to have a lot of data. And in challenging environment, you also need information. Information is always, or who has the information is the king, and therefore you need reliable data, and this is done or could be done via wireless M-Bus, for example. Some future trends, you will have hybrid networks, and therefore you will have the need to integrate different technologies, wireless M-Bus, coexisting with other LPWAN technologies like LoRa or narrowband IoT for broader connectivity solutions. You can enhance interoperability with wireless M-Bus, as others, perhaps cellular is already busy. You can use wireless M-Bus for other solutions. You can expand application areas. Of course, not only the base idea of metering applications, but also others are possible, as I already said also. And you have an advancement of technologies needed in the future, in battery lifetime, in battery technologies in general, and therefore also wireless M-Bus can be used. So I have a few points bringing in, and of course we can talk about it because we have a solution for this. And very short, you know a lot of about the benefits Würth Electronic has. We are supporting from the concept to the production in every single step, and especially for the radio modules, we have full service products with certification and with evaluation tools. And I want to highlight especially this point. You have a technical support where you can talk from engineer to engineer, where we can support you in bringing your application into life. And last but not least, the long-term availability also is very important, surely, as we have here, as I said, typically 8 years, 10 years, and of course you need the support on this time frame also. Our brand new solution is the METIS E module. It's a wireless M-Bus module based on a Texas Instrument chipset. It's with a very small form factor, only 12 by 8 millimeters, you see here, based on the OMS wireless M-Bus standard, and with 14 dBm output power, meaning 25 milliwatt, and supporting ST and C mode. Only add an antenna and then you can go. Connecting easily the module via UART to your microcontroller, for example, sending data over wireless M-Bus. And of course, we have a lot of other things for testing, especially I show here with evaluation kits, with feather wings, with the radio sticks, everything you need for developing your application. We want to support you there. And to come to a conclusion in the presentation, wireless M-Bus has a lot of advantages which could be very interesting for your applications. But of course, there are also limitations. Perhaps other technologies will fit better into your application or into your needs. And so there are also some alternatives available. And with application recommendations, you can easily find out what is the fitting solution, and we also love to help you with it to find the fitting technology. So I thank you for the attendance, and I welcome Markus back again. Hi.
Thank you, Michael, for your good presentation. And yeah, very interesting, all about smart metering and yeah, all the possibilities. There were a lot of questions already in the chat. It was very active. So also it is very nice to see you communicating out there.
Very good.
Yeah, so we will see if we have the chance to answer all your questions. If not, then we will answer them later via email. And yeah, but first, before we start into the session, I will also just share the handout. So now you should also be able to download the slides.
Perfect.
Okay, then let's start with this one. It was in the very beginning. Are there small libs for Python and special MicroPython?
Yes, surely they are available, and you can easily add it or communicate with these easy-to-use wireless M-Bus modules, and that you don't have to integrate it completely into your part of the application. That's the idea of these radio modules or chipsets. Also, that you don't have to be the radio expert, but you can easily use it as an interface.
Okay, thank you very much. Then the next question. What is the expected average or typical daily data rate in order to ensure a battery life of 15 to 20 years? How many times does the transmitter activate daily in such scenario?
It depends in the end, but you can sum it up. Of course, to bring or to reach these long battery lifetimes, you can send the energy meter level or once a day or something. Then you will meet such long battery lifetimes. You have smaller lifetimes if you take, for example, the 15 minutes section, every 15 minutes to send the data, for example, for some energy saving rhythms, or you need this 15 minute sections. Of course, there it's a bit lower, the battery lifetime, but also years are possible then.
Okay, Michael, thank you very much. Then there is a quick question. What is the difference between M-Bus and LoRaWAN?
It's in the end, the difference is the protocol. So you have wireless M-Bus and the LoRa protocol. There is one main difference. Wireless M-Bus is only a protocol difference, and in LoRa you also have some kind of a hardware you need. So Semtech is there somehow the license part, and you have to integrate it. But now there are also solutions available from, for example, from STMicro, and they integrate it into their chipsets, and then you can also use it, and then it's very, very comparable. But chipset side, it's a bit more expensive, the LoRa part.
Okay. Then the next question. Considering reception latency, how much time is the receiver able to receive communications?
That depends on the mode you use in the communication. But this is a bit too long to answer it now, but we can do it afterwards.
Okay, thank you very much. Then the next question. Is there available ISM 915 MHz with frequency hopping?
That's a very good question. I'm not completely sure whether this is available. This is something I would have to check and can answer it afterwards.
Okay. What is considered for small data?
Okay, so I can only imagine what is meant with this question.
I don't know on which slide it was.
Yeah. So 2.4 kilobit per second is small data in wireless M-Bus. so the smallest data rate which is available. I can only think that this is the answer of the question. But if it is not answered, get in contact with us.
Okay. So then we test your knowledge with the next question. Is there any limitation for duty cycle on transmission time as there is with LoRa, for example, with 1%?
Yes, it is, because that's on the whole sub-gigahertz part, there is a limitation that you have to fit to fit the duty cycle 1% or 0.1% depending on the output power. And yes, you have to have in mind.
Okay.
But basically, as I said, wireless M-Bus is not meant for sending tremendous data rates or tremendous data amounts. And so it is not typically used for big data. And perhaps important to know, if you didn't know, duty cycle is always calculated over one full hour. So you can send more data in the first minutes and then wait until the hour is gone. And so it's calculated over the complete 60 minutes.
Okay. I would quickly skip this question and stay with the LoRaWAN topic. So why would I choose M-Bus instead of LoRaWAN?
Especially if you want to send metering data, then wireless M-Bus has a few big advantages against LoRa, especially also this gateway topic, because you can collect easy the metering data. It's a bit easier than with LoRa, and LoRa also always has, as I said, the chipset topic that it could be a bit more expensive depending on the chipset you use, and yeah, a few points in the end about cost effectivity.
Okay, so then we go back to the question from Jens. Is there a main selling point compared to IEEE? I let the numbers out.
Yeah, 802.54.
Exactly. For example, for license costs, energy, energy consumption, data rate, or collision management.
Yeah, so the 802.15.4 is based on 2.4 gigahertz, right? And so there you have the benefit. It's worldwide usable, but you don't have the range. You get a few hundred meters, or in best case, you don't hit kilometer ranges with 802.15.4.
Okay, thank you very much. Then let's go on with the next question. We still have some time left and hopefully can answer more questions. If you include LTE-M in comparison table, why not also include Starlink?
Yeah, that's a good question. Of course, you can add 5, 10 or 20 other technologies also into this table. We've focused on the topics where we also have modules, so that we also are able to tell something with a technical background we have. So for LoRaWAN, for wireless M-Bus, and for cellular LTE Cat-M and narrowband IoT with electronic health solutions, and this is the reason why we chose these technologies into this table.
Okay. So then let's go on with this one. Tricky to read out. What is the advantage over the MQTT protocol, ISO, IEC, information technology, and also message queuing, telemetry transport, so MQTT?
I'm not completely sure what the question means. I think what is the advantage of wireless M-Bus over the MQTT protocol? In the end, I would say one benefit is time, so real-time possibilities, because you have the data directly in the gateway and you don't have to go the way through the internet as you have to do with MQTT. So if you want to have the data locally, you can do it with wireless M-Bus.
Okay, thank you very much. next question. Could With Electronics support me with samples of an evaluation kit?
Yes, of course, we can do, as I had shown on one of the last slides. We have evaluation kits for all the technologies, as I said before, and we can support you with hardware, but also with knowledge and with support here.
Okay. Then also this question, is there an application note?
Yes, there are a few application notes, and we can also send them afterwards to you about this whole topic.
Okay, thank you very much. Then for now, we just, we got it. Last question. What is the theoretical maximum data rate for M-Bus and power not considered and ideal conditions?
Yeah, it should be 100 kilobit per second. Should be the maximum data rate.
Quick answer.
Yeah.
Oh, that's good. Okay. So then hopefully all your questions are answered already. And if you have any questions, then feel free to contact us.
Absolutely.
Thank you very much for your attention, Michael. Thank you very much for your presentation. And
thank you for the moderation and thank you for attending. And as Marcus already said, if you have questions, we would love to answer them for you.
Exactly. Then stay tuned with our digital V-Days tomorrow, or no, I think, on Wednesday, we also have another session regarding to wireless connectivity, regarding demystifying Bluetooth. We also have a new radio module upcoming with the nRF54 chipset. So stay tuned. Maybe Absolutely. This is also interesting for you.
All the best. Have a nice day.
Bye-bye.